Hello, everyone. I'm Michael.
I'm Maggie.
I'm John.
Casey.
And I'm Tristan.
Together, we're the Kinetic Sculpture Project, Beacon in the Wind. Our project's requirements and constraints are that the sculpture must always be moving. Any material may be used, but the design needs to be entirely unique. The figure must fit in a 1 by 1 meter cube. The sculpture can have elements that are stationary as long as one of those elements are always moving. The team budget is only $60. This is an overview of the design cycle, and we'll go over this in more depth.
In the ask stage of our design cycle, we had to define what is a kinetic sculpture. In our definition, we stated that a kinetic sculpture is a work of art characterized by its ability to move continuously. It can move by gravity, wind, water, or electricity. Then in our research stage, we discovered Vincent Leroy and Lyman Whittaker. Both are kinetic sculpture artists. And Vincent Leroy's lens cloud, which is the image on the left, um, we were inspired by his usage of the glass to reflect light, and we decided to do that with our plastic sheets to distort the view of our surroundings. And Lyman Whittaker used wind resistance for his sculptures to continuously move, and that's the same process we would like to use in our sculpture.
So the next step in the design process was to imagine. So we had to decide how we wanted it to spin, what we wanted it to look like, while still remaining within the design constraints. So we had to choose between the different types of ways that it could spin, and we decided on wind. And then we had to choose what we wanted it to look like using like high contrast coloring or optical illusions, and to implement a design that would be visually appealing while still being able to catch the wind. So to do this, we decided that we wanted to use Mobius strips, which are like half twists. So when we put those around a central rod, we planned that those would be able to catch the wind and it would spin similar to Whitaker's work. So to test this design, we made our first prototype. This was just out of cardboard and paper. When we went to test this, though, we saw that having Mobius strips spinning independently of each other was design-wise hard to implement as well as visually unappealing. So this is where we had to kind of rework our design and go back a few steps in the design cycle. And it became really a major turning point in our project for what we wanted our new design to look like.
And so after that, we got to this stage where we were ready to put all our stuff together and test stuff. We had a few improvements, which we'll go over in the next slide. And we kind of decided that to make it spin, we were going to use ball bearings in our base and then let the Mobius strips catch the wind and allow it to spin. We did this by having a rod extending from the base, the Mobius strips connected. And then we also wanted some rods extending from the top of the base to give it some width and some aesthetic complexity. But when we went to try this, the test was not successful and it didn't spin, so we had to come up with a new way of catching. And in these pictures, you can kind of see some of the improvements we made, with the picture on the left showing where our ball bearings went, this picture in the middle showing the section that went in the base to allow the ball bearings and this rod to fit. And then this picture on the right was kind of a plan of our final design.
To improve our design to allow it to spin, as it did not spin earlier, we replaced the hanging Mobius spheres with sails made out of the same material as the original Mobius strips. This added surface area would catch the wind a lot more readily than the Mobius strips did. And for our final design, we decided to go for a nautical lighthouse theme with sails attached to the rods that would complement the lighthouse theme. We also printed out a topper and added a candlelight in it to make it look like a lighthouse. And on the right is a picture of our final design. Some challenges that we faced while doing this was our constraints at the beginning was mostly just create a structure that moves. And so we had to really narrow that down to one final design. It was also difficult to have our design actually spin in the wind and fixing any flaws that turned up, as well as balancing it moving with it looking aesthetically pleasing. Some solutions we had to this were we focused on systems thinking when figuring out flaws to really get to the core root of any problem. And also, we found that we had to prioritize the mechanics over aesthetic until we had our design finally moving in the wind, and then we could focus on the visual appeal. Some advice for future teams is start your project way earlier than you would expect. It takes time to rework any ideas you have.
Uh, Piece of advice I would give is to not be afraid to make changes at any stage of the process.
Yep, I would say that sometimes it's easier to scrap your idea completely and begin anew than to try to keep reworking an idea that may be doomed to begin with.
My advice is to believe in the process and make your design functional.
My advice is to have a backup plan because sometimes plan A does not work out.
And we won. So we're proud of that. And with that, that's about it. So thank you. And these are our sources.